Hello everybody, this is Mr. Longo here, and this video is going to cover two-way tables and the probability that we can do with them. So, a couple of definitions. We have joint frequency, which is just an individual entry in the table, and marginal frequency, which is the sum of the rows or columns in the table. So this table is going to represent the results of a survey given to juniors and seniors about going to prom. So if we were to look through this, we will find out that 140 juniors are going, 60 are not, out of 200 juniors. 160 seniors are going, 40 are not, out of 200 seniors. And then if we were to look going down the columns, we have 300 students attending and 100 that are not, for a grand total of 400 students. So in this, these will be our joint frequencies, any one of those four. So just the individual category. So those are our joint frequencies. Our marginal frequency would be the totals of students attending or not attending, or juniors or seniors. Those will be our marginal. And then the last thing we have is the absolute total number of students, or the total that were surveyed. So now you kind of have an idea of what a two-way table is. It's used to, organize data. But now we can do multiple things with that two-way table. So we have a joint relative frequency, which is an individual entry over the total surveyed. So this is a probability. So the probability is that a random student is selected is a junior and attending prom. So whenever we're talking about probability, you have to remember it's kind of the success over the total in that specific group that we're talking about. So the total is just a random student selected. So that's going to be our total, or the pool of students that we are allowed to select from. And this student has to be a junior and attending prom. So this is a joint relative frequency because we're taking one of the joint pieces, in this case juniors that are attending prom, so that would be junior and prom, divided by total students. So junior and prom would be 140. And there's a total of 400 students. And of course that would reduce to 7 over 20, which is 0.35 or 35%. Okay, so 35% of the students going will be juniors. Okay? The next type of frequency that we can get from a two-way table would be a marginal relative frequency. So that means just a marginal total over the total surveyed. So what is the probability that a random student, it's not broken down to any group, so we have just a random student again, selected is not attending prom. So this is all of the students. So this would be not attending over total. So we have 100 students not attending out of 400. So we know that that's 1/4 or 0.25 or 25%. So 1/4 of the population is not going to go to prom. And again, that's out of a pool of all possible students. Okay, so that's what a marginal relative frequency is. Our last example for this two-way table is a conditional relative frequency. So in one of the videos we talked about conditional with our independent and dependent probabilities, and that is based on a certain group. So in this, it's an individual entry over just a marginal total. And let's read the question so you can see why. What is the probability that a random senior, so our total group is just out of seniors. Notice it doesn't say a random student. So this probability is only allowed to include seniors. Okay, and that is attending prom. So this again goes back to conditional. One of the examples we did in the video, I believe, was deep dish pizza out of people that order pizza. So this is seniors and attending prom over just seniors. Okay, this is not over the total because it says what's the probability that a random senior. So you're only allowed to select a senior. And then we're going to find out if he or she is attending prom or not. So what's the probability? That would just be seniors and attending prom would be 160 over just the total number of seniors in that row, and that was 200. Okay, so that would be 4/5, which would be 0.8 or 80%. So 80% of seniors are going. Okay, so that's how it kind of works. It's 80% of seniors. It's not 80% of the total student body. Okay, so that is a two-way table and some probabilities that we can get from them. So the next example is going to cover the same thing. However, the first thing you have to do is read through and organize all of the information that's given and then find any missing pieces. So I can tell you that there is enough information here. Now, the one thing you might want to do is read through this very carefully first and come up with what you need in your rows and columns. Now, normally you'd have to draw your own table, so you would have to count how many you need and, of course, have a row for totals and information. So these guys are going to be our totals. And then you have to read the information. So you have a survey given to 500 seniors about what type of college they plan on attending next year. 275 female students took the survey. 205 are going to a 4-year university. And then there are 45 male students that are planning on going to a community college. And only 50 students have decided not to attend any college, with 35 of them being male. So the first thing you're going to want to do is read through the entire paragraph to find out what kind of information you have. And by reading through that, you should have figured out that this is going to be based on male or female. And there are 3 different types of colleges, because we have a 4-year college, we have a community college, and we have no college at all. So, I mean, we do need to have a column that talks about the option of not going to college, okay? So now what I would like you to do is pause the video and try to fill out all of your numbers. Yes, you're going to have some missing pieces, and you're going to have to figure all of that out on your own. And as soon as you're ready, click play, and we'll see what we come up with. So the first thing it says is a survey was given to 500 seniors. So we have a grand total of 500 seniors that took this survey. Okay? And of the 275 females that took the survey. So we now know the 275 are total females. So we have 275 females. And of the 275 females, 205 of them are going to a 4-year university. So we have 205 females going to a 4-year university. Okay? And then it says there are 45 male students going to a community college. So we know that male and community college is going to have 45. And then we also know that 50 students have decided not to go with 35 being male. So 35 males are not going to go out of a total of 50 students not going to college. Okay, so now we can use what we have to figure out the rest. So if 500 seniors took it and 275 of them are female, that means we know that 225 of them have to be male. And we also know that if 50 students are not going to go to college, if 35 of them are male, then 15 of them have to be female. Now we can look at the total number of males and females and decide that if 225 of the students are male, 35 are not going, 45 are going to a community college, that leaves 145 males that are going to go to a 4-year university. And we can also look at females. We have 275 of them, 15 are not going to college, 205 of them are going to a 4-year, that leaves 55 left attending a community college. And then of course the total for 4-year, we would just add this up and get 350 students going to a 4-year college, and we would have 100 students going to a community college, and of course we can add those all up to make sure they add up to 500. They do. So now our table is complete. Once your table is complete, you can start using it to find probabilities. So remember, we have to know the difference between what our total pool is. So if we have, what is the probability that a student selected? So this is a student selected at random, of course, but this is under our total amount of students, which is 500. And then we have this as a female that is going to a community college. And a female going to a community college is 55. Okay, so remember the probability is female and community college all over the total number of students. So that would be 55 over 500. That would simplify to 11 over 100, which we know is 0.11 or 11%. Okay? So that is what we're going to do again. So why don't you take the time to answer the next 3 questions, all on the table that you have. Press pause as soon as you're ready. Click play and we'll see if you did them right. Give them a shot. So our pool of students for this one is a student selected at random. So that is, again, all 500 students. And this is going to a 4-year university. So this is one of those marginal totals. So there were 4-year over total. There are 350 students going to a 4-year university out of 500, which of course will reduce to 7 out of 10, which is 0.7 or 70% of students are going to go to a 4-year university. Okay? So if you got that, you're good to go. We have to look at our pool of students for this next one. What is the probability that a male selected at random? So now we are only allowed to talk about males. And in this two-way table, we have 225 of them. And it's that are planning on not going to a college. And from earlier, we read that there are 35 males not going to college. But this one, again, is different. This one is not going out of total male only, not the 500 total students. So that would be 35 out of 225, which is going to bring us to 7 over 45, which of course is equal to 0.156 or 15.6% not going to college. Okay, and the last one. What is the probability that a student attending a 4-year university? So this is going to be from the pool of only students attending a 4-year university, randomly selected as female. Okay, so this one, again, is going to be female and 4-year out of a total of 4-year. And that would bring us to 205 out of the 350 total going to a 4-year university. And that would be 41 out of 70, which is 0.586 or 58.6%. Okay, so that's your video on two-way tables. Again, it's no different type of probability that we've already talked about. I mean, it is going to have some that are dependent, and some are really easy because you just need a total, but some you have to pay attention of the pool of students you're selecting from. So you do have some conditional probability going on in here, but if you have an accurate table, they're pretty easy to read and keep your organizational information. So all you have to do is then use it. You just have to think about what you are trying to find the success of out of a certain pool of students, okay? And it's very specific on what you are selecting the student from. Okay? This is Longo and I'm out. See you, bye.